Good day. Welcome to our page. So if you are watching from Facebook, please follow. If you're watching from YouTube, please subscribe. This will help us to keep on making videos. So this is our first ever video that we are making using the stylus pen. So let's just see how this goes. So just bear with me. This is still new to me. I'm also learning how to use this. But however the situation is, I'm still going to deliver the best of me. I'm going to give you the best of me. So today we are on Newton's laws, grade 11 and grade 12. So I'm just going to explain everything that you need to know for you to pass your exams well as Newton is concerned. So I'll just explain all the details that you must master so that you can be a pro on answering these Newton's laws. So obviously, first thing you need to understand what is a force. Since in this topic we'll be dealing with forces a lot, so you need to master or you need to understand what is a force. So a force is basically a push or a pull. So if you're having an object and then you push or you pull that object, you've applied a force. So this is a push or a pull, right? So we have different types of forces. We have non-contact forces. Non-contact forces, they include gravitational force, electrostatic force, and magnetic force. So these are actually the forces that an object can experience without being in contact with the force itself, or without being in contact with the applier of the force. So those three are non-contact forces. And you also have what you call contact forces. So contact forces, it is self-explanatory. So these are the forces which includes an object being in contact with the applier of the force. So this includes force applied, tension, and frictional force. So don't worry about them now. I'll explain each and every force in details. So apart from that, you also need to know this type of forces and how do they mix around in the topics that you deal with, mostly in mechanics. So we have what you call a constant force. So a constant force is a force that when applied to the object, it is not changed or removed. So this force will forever be on the object up until the whole path is completed. This is the constant force. So it doesn't change. The constant force doesn't change. And we also have what you call non-contact forces. So non-contact forces, these are the forces that can be removed or that can be applied only once to the object and it is not applied again. So this type of forces or this type of non-constant forces, we find them mostly in the topics like vertical projectile motion. So in vertical projectile motion, if you remember, you can only apply the force once to the object and then you let it go like that, and then it will experience the free fall. So apart from that, it means that we also have what you call the constant force, and in the constant force we apply them in topics like Newton's laws, definitely Newton's laws, and work, energy, and power. So these topics, they deal with constant forces that are applied to the object throughout its motion or throughout the whole process. So now you know the difference between a constant and a non-constant force. So obviously you also need to remember, or you also need to know what happens when a force is applied to the object. So when the force is applied to the object, it can change the shape. So you know when you apply a force to a fragile object, it can change the shape. Maybe it can be crushed or it can just deform. And you also, when you apply a force, it can move or stop depending on the situation, on how the force is being applied to the object. And it can also change the direction. So this is one of the things that happens when a force is applied to the object. It can change the direction, and also it can accelerate. So what is to accelerate? This is when the velocity is increasing. So this is also what happens when a force is applied to the object. However, in this situation, in Newton's laws, the only things that we deal with is when the object accelerates, or when the object starts moving, when a force is applied to it. So we don't deal with the changing of the shape. We don't deal with the changing of direction. We only deal with the acceleration when a force is applied. So let's see, or let's talk about all the types of forces that you need to know to master Newton's laws. So the forces that you need to know in terms of this, you need to know what is gravitational force. What is the gravitational force? So each and every object in the universe, as long as this object has mass, it has gravitational force. So this is the weight. We also call it the weight of the object. So this is the force that each and every object experiences due to the Earth's pull. The Earth pulls each and every other object to its center. So it depends on the position, however, of the object. That where is the object? So gravitational force differs in terms of the position in the universe. So on Earth, we take this generally as the gravitational force as 9.8 meters per square second. At Earth, we take this as 9.8 meters per square second. However, in some of the countries or in some of the syllabuses, they will write the gravitational acceleration to be 10.0 meters per square second. But however the situation, the gravitational force remains constant in different positions. Right. So now, how do you calculate the gravitational force? And I also show the different situation in which you can have gravitational force being applied to the object. So in case 1, obviously we talk about when we are having an object maybe on a flat surface. So if we're having an object at a flat surface, this gravitational force, we show it like that. So this is perpendicular downwards. So just take this as perpendicular. I'm sorry for the drawing, but this is perpendicular downwards. And how do you calculate that Fg now, or the gravitational force, or the weight? We calculate it using the mass of the object multiplied by the gravitational acceleration, which the gravitational acceleration, we say that it is constant depending on the position, or depending on how they are taking it at that situation. So it can be any of those. But however, in caps, we use the gravitational acceleration as 9.8 meters per square second. So this is how you can calculate the gravitational force, like that. So obviously we have other scenarios where we can have an object moving up a slope. So we can have a slope inclined maybe at the angle of theta there. So we can have our object like that. So if this object is moving up the slope, this object, we have the Fg, that's true, which is perpendicular downwards every time. But now in this case, now this Fg, we have components. It will have 2 components. It will have the F at x and it will have the F at y. So what is the F at x and what is the F at y? So this force, as you can see, it is acting at an angle. So if we can extend this we call it Fg perpendicular, or we can call it Fg at y. So this is the component that is perpendicular to the plane of the object. So we can see that this is the plane where the object is moving at. So if we are having our object there, it means that our FG perpendicular or FGY can be shown like that. And we can also have our FG parallel to the plane now. So this X to the plane, and it is always acting downwards. So how do you calculate FG at X and FG at Y? So remember I said that this FG, so we say this is FG parallel, or we can call it FG at X. So this FG perpendicular, we calculate it using FG perpendicular is equals to FG cos of theta. So FG already explained what is FG, so it means that to calculate FG perpendicular, we can use mg cos of theta, like that. So this is how we can calculate the perpendicular component of this force. Remember, in vectors, we know that if a force is acting at an angle, it will have two components, the y component and the x component. So just like that. And we also have the FG at x. So how do you calculate the FG at x now? So to calculate the FG at x, we use FG sine of theta. So theta is representing the angle that is between the flat surface and the ramp, or the surface in which the object is moving at. So this is equivalent to say FG at x is equivalent to mass gravitational acceleration and then sine of theta, just like that. So already you know two formulas already in this Newton's laws. So now if our object is moving down the ramp, so if our object is moving down the ramp now, nothing has changed, just that now the FG at x is now in support of the object. Because if you can check previously, the object was going up, but the FG at x is going down. So now the FG at x, or the FG parallel, is kind of like opposing the motion of the object, right? So you understand more when you're doing the equations of motion. So always remember that on an incline, we have FG at y, which is FG perpendicular, and FG at x, which is FG parallel. And FG parallel always affects the motion of the object. If the object is moving up the slope, it means that our FG at x, or our FG parallel, it will act as a negative force. But if your object is moving down the slope, our FG parallel, or our FG at x, is now acting as a positive, since this force is going in the direction where the object is going. So this is all about gravitational force. So don't forget the formula to calculate the gravitational force itself. We said Fg is equal to mass times gravitational acceleration, which is constant. We said it is 9.8 meters per square second when we're talking about the KEPS syllabus. So also you need to understand what is the normal force now. So the normal force, this is a force that the plane exerts to the object that it is in contact with. So once the object is in contact with the surface, it means that there's a normal force that exists there. So it will also mean that if the object is freely hanging in, not on any plane, it means that now it doesn't have normal force. So this force only exists when the object is in contact with the surface. That's when the normal force is present. And also it is perpendicular upwards from the surface. So it means that if we're having our surface like that, it means that our normal force will always be perpendicular upwards, something like that. So that will be our normal force. And if maybe we are having a slope, if we are having a slope like that, so it means that also it should be perpendicular to the surface. However, the situation, the normal force will always be perpendicular to the surface. Always remember that. So before we talk about how to calculate the normal force and everything like that, let's talk about Newton's third law of motion. So that's how I teach Newton's laws. I start with the Newton's third law, the action-reaction law. So what does this law say? It says that if body A exerts a force F on body B simultaneously exerts equal force F on body A but opposite in direction. Right. So once you understand that, since we say that each and every body has weight or gravitational force, so when this object that we're talking about is in contact with the surface, it means that the object is giving the normal, the gravitational force to the surface. So now the object is acting as body A and our surface is acting as our body B. So this object of ours, it will exert a force on the surface, and this force, we say this force is the Fg. So this surface has to also act and also exert a force on this object, body A, that is equal in magnitude but opposite in direction. So it will exert a force upwards, since this object is exerting a force that is downwards. So it means that this force now, it will be upwards, and you call this force the normal force. So they say that this normal force balances the Fg, because if this force, the Fg, is not balanced, it means that our object has to move down. But the normal force is there to balance this Fg. So I'm going to talk about different scenarios in how you can calculate the normal force. But basically, on a flat surface, when nothing else is going on, we know that our Fg will be equivalent to our normal force. So let's explore on this normal force. So if you're having a flat surface, let's say we're having a flat surface like that, and we're having our object like that. So as I explained, that this object is going to give the gravitational force to the surface. So this gravitational force is going to be balanced, or is going to be, or this surface is going to exert the equal force but opposite in direction, and we call that normal force. So it means that on any flat surface like that, it means that our normal force is equal to our Fg. And how do you calculate our Fg? This is mg. Don't forget that. So this is on a flat surface. This is what happens. Our normal force will be equivalent to our gravitational force, just like that. So now let's talk about the case 2 or scenario 2. Still we are on a flat surface. So again, I'll take you back to vectors. Don't forget what you did on vectors. So if this object is giving off the gravitational force like that, we say this is the Fg, because it is having the mass. And also happens that this body is acted upon by a force that is acting at an angle, maybe angle theta there, right? So we're having the angle theta there acting on the object. So according to vectors, what we did on vectors, we know that, okay, maybe before I talk about that, it means that also here we are having normal force. But we want to understand how we can calculate that normal force, right? So in this situation, remember that this force applied, it will have two components. It will have F at X and it will have F at Y. So F at X, it is the force that will be like that will act parallel to the plane. This will be our F at X, and this object will also have the F at Y. So the F at Y, it is this force that will act upwards like that, right? So this is our F at Y. So as I explained, that normal force, mostly it is there to balance the unbalanced forces that are acting up and down. So how do you calculate F at X? Before I forget, F at X, you calculate it using F cos of theta. So theta being the angle at which this force is acting at. And to calculate the F at Y, this is F sine of theta. So the F is standing for this force that is applied at an angle. So in vectors, we know that if this object is not making up and down motion, it means that the up and down forces are balanced. So it means that this force plus this force plus this force must give us 0. So what is the resultant vector, or what is the resultant force? This is the sum of all forces acting on a single object. So now it will mean that our Fg plus our normal force plus our F at Y must give us 0, since we are saying that there is no up and down motion, meaning that the up and down forces are balanced. So now let's choose the direction. So perhaps let's say our up is positive. So that's what you do when you are dealing with vectors. You have to choose the direction. So it means that our down now becomes negative, just like this. So now it means that since this one is going down, we are going to say minus Fg plus the normal force, which is going upwards, so it is positive, plus the F at Y becomes 0. But our main task here is to find the normal force. So now it means that our normal force becomes, so we're making this subject of the formula, so we can take this that side and it becomes positive. This one is positive and it becomes negative. So this becomes our Fg minus our F at Y. So this is when we are having a situation like this, when a force is acting at an angle. So this is the formula that you can use to find the normal force. So the normal force will be equivalent to that. I hope you can see how this one is going. So now again, let's have another situation where still we're having a flat surface, but however now the situation has changed. So let's take it to still having our object like that, and we're having a force that is acting at an angle, but now it's more like it is suppressing the object, like it is pushed down at an angle. So still let's have our angle theta there. So here again we're still having the Fg, and we're still having the normal force. So this is the force that is being applied, but you can see that in this situation and in that situation they are different, because this one is more like the object is being pulled at an angle, and this one the object is being pushed at an angle, if you can check that. So now how do we deal, or how do we find our normal force? So also this force here, this force applied, still it has two components. It has the F at X and the F at Y. So F at X, it will be a force that will be going in that direction, like that. And our F at Y is now more like it's going downwards now. The F at Y is now going downwards. Because remember, if you're having a force that is acting like that, this force is more like it's in the third quadrant, if you try to think about it. So I hope your maths game is good. So if this force is acting in the third quadrant, obviously it will have our f at y in this situation, and it will have our f at x like that. So now how do you find the normal force now? So now it is quite evident that our f at y is going downwards. So these two must balance the normal force, because we said there's no up and down motion. So it means that again our Fg plus our normal force plus our F at y, we must get 0. We must get 0 if we add this, because there's no up and down motion. So now, since our Fg is going downwards, it is negative. So this is negative Fg plus the normal force is going upwards, so it is positive, and our F at y is going downwards, so it is negative F at y. So this must give us 0. So taking Fg and F at y to that other side, making normal force subject of the formula, it means that our normal force now becomes our Fg plus our F at y. In that situation, you can see what is going on there, right? So now on the last scenario that I can talk about, or maybe second from last scenario, it is on the inclined plane. How do you find the normal force at an inclined plane? So let's draw our inclined plane and let's have our object. So we say that this object, we have Fg. Like I said, Fg is always perpendicular downwards. Remember that. Yes. So this is acting at an angle theta there. So we have our Fg, and we also have our normal force, which is perpendicular to the plane, like that. So this is our normal force, this is our Fg. So I said Fg, according to this situation on an inclined plane, it has two components. So it has the Fg perpendicular, or some they refer it as the Fg at y, and it also has the Fg at x there, or the Fg parallel. So this is also called the Fg parallel. So as you can see, this situation, we are only having two forces that are acting up and down. So we're having the normal force and we're having the Fg at y. So these two forces must balance out so that this object won't move up and down. You can see that. So now it means that in this situation, to find the normal force, we must say normal force plus the Fg perpendicular must be equals to 0. But since our normal force is going up, so it is positive. So our normal force being positive, and our Fg perpendicular is going down, so it must be negative. Fg perpendicular must be equivalent to 0. So in this situation now, it means that our normal force becomes Fg perpendicular. Once we take this to that other side, it becomes positive. So that is the situation that can happen when we are on the inclined plane. And last situation is now when we are on the inclined plane and also the force is acting at an angle. So we are having this object of ours, we are having Fg that is perpendicular downwards, and we are having Fg at y. And we are having the normal force perpendicular to the plane. So this is our normal force like that. So maybe let's say we're having another force that is acting at an angle theta. So this situation is a bit complex. You can see that. So let's break this bit by bit to see how we can deal with this one. So here you must not forget that this force, it will have two components. It will have the F at y, right? So this is the force applied. It will have F at y and it will have F at x. But at this situation, we're not interested in F at x, since F at x is acting parallel to the plane. Now we want to deal with the up and down forces that are acting in the y component. So it means that this F applied at y, which will be there, right? F at y, it will be there. So our F at y plus our normal force plus our Fg perpendicular, we must get what? We must get 0. Since when these two forces adds with this one, we must get 0. These are the upwards and downwards forces. They must balance each other out. So our force at y plus our normal force plus our Fg at y, we must get 0. So now our F at y, it is going upwards, so it is positive. And our normal force is going upwards, it is positive. And our Fg at y, it is going downwards. Our Fg perpendicular, it is going downwards, so it is negative. So negative Fg at y must give us 0. So now taking everything that other side to get the normal forces that are subject to the formula, it means that now our normal force becomes Fg at y. So this going that side, it becomes positive, and this one going that side, it becomes negative F at y, like that. So this is the other situation that we have to calculate the normal force. So calculating the normal force depends on the plane. So it depends on two things. It depends on the plane. It's either it's flat surface or it's inclined surface, and also it depends on the force applied. Either the force applied is at an angle or not. So these are the two things to consider before calculating the normal force, right? So let's go on to the next force that we can talk about, being the frictional force. So what is the frictional force now? This is the force that opposes the motion of an object, but actually it opposes the applied force. If you just understand, it can oppose the applied force or it can oppose the motion of an object. So this acts parallel to the plane. So this will always be parallel to the plane. So it means that if you're having an object, maybe the object is moving there. So between this plane, or between the surface of the plane and the surface of the object, there is frictional force. So this opposes the motion. If the object is going there, it means that our frictional force is going in the opposite direction. So the frictional force strongly depends on the normal force of the object. So this depends on the normal force of the object. That's what you have to understand. So it means that if it depends on the normal force, we can say that our frictional force is proportional to our normal force. So if our normal force increases, it means that our frictional force also increases. If it decreases, it also decreases. I'm sorry guys, this flu is killing me. It's killing me. So this is what you have to understand. So there are two types of frictional force. We have static friction and we have kinetic friction. And you are going to talk about that shortly. So just like I explained, I said the frictional force is directly proportional to the what? To the normal force. So the more the normal force, the more the frictional force. So what is static friction now? So static friction, it is the frictional force that acts on the objects that are stationary. So if you're trying to apply the force there to make this object move, if you're trying to apply a force to make this object move, when this object is failing to move, it means that there is frictional force that is on this object. There is frictional force that is not allowing the object to move. So we call that static friction. So to calculate static friction, we use F as max being equals to the coefficient of static friction multiplied by the normal force of the object. So what is this now? The coefficient of static friction. This coefficient of static friction, so coefficient of static friction. So this coefficient of static friction depends on the surface. So this depends on the surface. So there are some surfaces that have the coefficient very big, and there are some surfaces that are a bit smooth than this one. So it means that the coefficient will be less than that. However, the coefficient, be it the coefficient of static or be it the coefficient of kinetic friction, is no units. So this one is no units. This is the coefficient of static friction. So what is kinetic friction now? So kinetic friction, it is the frictional force that exists on moving objects or the objects that are in motion. So once this object is moving, it means that it has kinetic friction. So we show kinetic friction by that. So if the object is moving that way, it means that this frictional force, it will be moving in the opposite direction. That opposes, it tries to oppose the motion of the object. And to calculate kinetic friction, we use the coefficient of kinetic friction multiplied by the normal force of the object. So now you can see that the normal force is very, very important because it also helps us to calculate the kinetic friction, the static friction, or however the situation. But always remember that the normal force is very important in calculating the frictional force. So now you understand this type of forces that we talked about. Let's move to other forces.